All right, so I wanted to do this problem, which I think is one of the trickier problems out there. And one of the hardest parts about it is it gets too tricky super quick. Like part B is one of the trickiest parts, and usually they wait till part C or part D to throw that type of stuff at you. But well, we'll talk about it when we get to that part. So the first question, first part says find the second derivative, which shouldn't be too bad. I'm going to take the derivative of this. I'm going to get 3 plus 2 dy dx, and dy dx is equal to 3x plus 2y plus 1. And so I get what? I think I get 5 plus 6x plus 4y. And in the rubric, it's interesting. They require that you show this. I think you could probably use a y prime instead of a dy dx, but they do require that you show that step. So it is important to get used to your work here. So now part B, I think, is the well, it's tricky. So it says find the values of the constants m, b, and r for which y is equal to m x plus b plus e to the rx is a solution to the differential equation. And so what does that mean? Well, we have this equation, y is equal to mx plus b plus e to the rx, and dy dx is equal to 3x plus 2y plus 1. And I have to think of when will these be true. Well, they'll be true when the slope of this dy dx is equal to m. What I'm doing right now is I'm taking the derivative of this, m plus r e to the rx. That has to be equal to 3x plus 2y plus 1. Remember, this is for all x and for all y, and we know what y is. We know that y is defined explicitly as a function of x, which is mx plus b plus e to the rx plus 1. And so I can make this m plus r e to the rx equals, let's say, x times 3 plus 2m plus 2e to the rx plus 1. Okay, so we have to consider two different scenarios here, okay? So first scenario is, let's say that r is not, well, all right, let's do this scenario first. Let's say r is equal to 0. If r is equal to 0, it's going to turn this term into 0, and it's going to turn this term into 1, okay? So that makes it a little bit easier. I get the equation m is equal to x times 3 plus 2m plus 2 plus 1, and I get, and at this point, I know that this is only going to be true if it's true for all x's. The only way this is going to be true for all x's, this equation, is if this part right here becomes 0, because x can take, if x goes 1, 2, 3, 4, 5, and that doesn't affect the balance here, that's only going to be true if something else neutralizes it, which is this part. If we make that equal to 0, we get 3 plus 2m is equal to 0, which means m is equal to negative 3 halves. And so then I can go on, m is equal to negative 3 halves, r is equal to 0. Now I get negative 3 halves. Let's see. What did I forget here? I've forgotten that there's a plus 2b in here. Okay, so negative 3 halves is equal to 2b plus 3. And so then 2b is equal to negative 9 halves, or b is equal to negative 9 fourths. Okay, and so that's scenario 1. Remember, we're still only on part B of this question. And now we have to figure out when r is not equal to 0. So when r is not equal to 0, I have m plus r e to the rx equals x times 3 plus 2m plus 2e to the rx plus 2b plus 1. So I could write this as m is equal to x times 3 plus 2 to the m plus e to the rx times 2 minus r plus 2b plus 1. Okay, and so now keep in mind, x can take on any different value at once. These letters m and r and b, they're constants. They're not going to change within the equation, but x is. So it's only going to work for all values if this is 0 and if this is 0. Well, how does that happen? Well, first, r is going to equal 2. M is going to equal negative 3 halves. And then we have this equation, negative 3 halves is equal to 2b plus 1. 2b is equal to negative 5 halves. b is equal to negative 5 over 4. Boom. Okay, that's part B. All right, remember, there's still 2 parts left. Part C, let f of x be a particular solution to the differential equation with the initial condition f of 0 is equal to negative 2. Use Euler's method if you prefer mispronouncing his name, so sometimes I do, starting at x equals 0 with a step size of 1/2 to approximate f of 1. Show the work that leads to your answer. And notice that this is a differential equation where you have a plus in between the x and the y expressions. Not a multiplication, not a division, which means they're inseparable. You separate the dy from the dx by multiplying both sides by dx. So there is no real way of saying, like the y's and the dy's have to be multiplied. There's no way of saying 1 over 2y dy. Okay, there's just no way of separating it, which means there's no way of finding a closed form solution for y. However, there is a process for approximating it that we'll use called Euler's method. And the way Euler's method works is, well, we're going to think of us starting at a point. And the point is going to be negative 2. And we have an equation for dy dx. I think that's right, 3x plus 2y plus 1. So we can plug the numbers in to dy dx. And in this case, if I do that, I get negative 3. And then we're going to take a step in that direction. And the problem's going to tell us how big of a step size we're going to take. So we're taking a step of size 1/2, which means that we're going to put our x foot forward, and we're going to take a half step. So x is going to go up by 1/2, which means y is going to go up by, well, the slope is negative 3, but it's only going half of negative 3, so it's going to go negative 1.5. So if we think of what our new point is going to be, it's going to be 0 plus 0.5, which is 0.5, and it's going to be negative 2 plus negative 1.5, which is negative 3.5. Okay, and if you put these numbers in to this expression again for x and y, you get negative 4.5. And then I'm going to put my x foot forward again. I'm going to take a half a step, and my y is going to go up by half of that, which is negative half of the dy dx, which is negative 2.25. And so now my new point is going to be 1 comma negative 5.75. Okay, and this is your solution here. And part D says, let g of x be another solution to a differential equation with the initial condition g of 0 is equal to k, where k is a constant. Euler's method starting at x is 0 with a step size of 1 gives us an approximation of g of 1 is approximately equal to 0. Find the value of k. And I'm sure And most students who get to this problem have given up by now. And that's fair because it's super challenging. And once a problem confuses you, it's hard to come back to it. But this is not that difficult if you can get a grasp for what's happening and understand what we did with Euler's method. We're going to start at 0, k. We have this formula dy dx is equal to 3x plus 2y plus 1. If you want us to make it into a table, if you want me to make it into a table like I did last time, dy dx is going to be 2k plus 1, okay? And then delta x is going to be 1, delta y is going to be 2k plus 1. My new point is going to be 1, comma, k plus 2k plus 1. And what I really want to know is what k value makes that equal to 0. So 3k plus 1 equals to 0, which means k is equal to -1/3. That's how you get that answer.